Today we will continue the topic which is connected with the scales for measuring earthquake parameters. As we discussed previously, first and most widespread scale is Richter scale. It is the scale which works only with specific equipment, with specific devices like seismograph, and only by analyzing the records of seismograph we can define the magnitude of the earthquake, because Richter scale is measured in magnitude. Next scale that we will discuss during our lectures is intensity scale. Intensity scale is the engineering scale. And all building codes are connected with those scales. Euro codes, Ukrainian codes, other country codes are connected with the intensities. Or I can't remember any. I can remind any building codes which operates with the magnitude of earthquakes. That is why this topic is very important for us. We had to discuss Richter scale because it is very important for us to know how that scale is connected with our intensity scales. And by the way, it is very important for us to know both scales, because only understanding of each of those scales give us an ability to understand the complete earthquake situation, which is connected with certain destructions, with certain effects on the ground surface, with certain effects underground, and with the amount of energy which was emitted from the source of the earthquake. And last lecture we have discussed Richter scale, and we discussed the amount of energy. We remember that each complete magnitude each complete magnitude differs from the previous magnitude in 10 times. Magnitude 3 less than magnitude 4 in 10 times. And we are talking about displacement. Displacement in magnitude 3, 10 times less than displacement in magnitude 4. And magnitude 3 differs from the magnitude 5 in 100 times from the point of view of displacement. But when we talk about energy, seismic energy, then energy that was emitted from the source of earthquake in magnitude 3 from the magnitude 4 differs in 33 times. But this energy is also connected not only with displacement and not only with the emitted energy, but it is also some kind connected with the destructions of the structures. One more time in Ukrainian. Ми пам'ятаємо, що магнітуда 3 від магнітуди 4 відрізняється в 10 разів. Ми пам'ятаємо, що це в нас логарифмічна шкала землетрусів, а магнітуда 3 відрізняється від магнітуди 5 у 100 разів. При цьому магнітуда 3 від магнітуда 4 не по деформаціям, а по енергії, що була у гіпоцентрі вилучена, вона 3 від 4 відрізняється у 33 рази, а 3 від 5 відрізняється у 100, вибачаюсь, у тисячу разів. І ми пам'ятаємо, що нам ця шкала необхідна для того, щоб проаналізувати, яка енергія була у гаслі землетрусу. А якщо ми далі будемо у джерелі землетрусу, а якщо далі ми будемо розглядати цю історію, то ми будемо аналізувати, а як саме ця енергія, що була у гіпоцентрі, як вона вплинула на конструкції на поверхні. І саме для цього нам необхідна шкала інтенсивності. Discussion of this scale, I'll start from the practical point of view. So, how can we measure the intensity of the earthquake in Odessa in 1802? uh, on 1802 we had only a Chinese device for the earthquake registration, and that device, as we discussed previously, helped us only to find the direction of the earthquake. And how can we know what amount, what intensity of an earthquake was in Odessa in 1802? And to solve that problem, we have to analyze the intensity scale. These two pictures are from European microseismic scale. It is almost the same that Ukrainian, but that in Ukraine. So how this scale works? First of all, we have to define what structural scheme are we analyzing. So in this case, we are having a deal with unreinforced masonry, and in this case, we have a deal. We work with reinforced concrete walls. So when we have find out the structural scheme of the building, we have to find the certain blank for that building. For each type of building, for each structural scheme of building, we have certain blank. We have one blank for unreinforced masonry. We have another blank for reinforced masonry. Additional blank for reinforced concrete walls. Additional blank for flat slab. Buildings, and those that collection of forms is in European microseismic scale or in Ukrainian scale, which called the band scale. Uh, so, first of all, we have defined the structural scheme of building. Then we have to analyze which level of destruction have we found. Zero grade of damage means there is no any crack in building or in structure. When we're talking about grade of damage equals 5, that means that building has totally collapsed. So zero, no cracks at all, or no damages, no deformations at all. 5, total destruction. We have in this scale we have additional sheet of paper we discuss that helps us to find out what means deformation 1, grade of damage 1, the grade of damage 2, 3, etc. So this this deformation shows us that our building had got deformation with the level with the grade of damage number 3. In this case, we have almost the same deformations, but those deformations were in reinforced concrete walls. And we understand that we have same level of deformations, but those buildings are not equal. And we have to admit that one of these earthquakes is significantly bigger than the other. And I want you to ask me what for what picture earthquake was more intense. 1 second, I'll show it to you. You see these deformations and these cracks. What? Yeah. Near the windows deformations, but they those deformations are the same as on the left picture between the windows, and here we can see between the windows, and there are also these incline cracks in the buildings, and those cracks are almost the same as these cracks. And I want you to tell me how do you think this earthquake was more intense, or this earthquake was more intense? Was the strongest? Yeah. Okay, and here is the moment, the truth moment. I will explain you. So, how do you think? What this building or this is more seismic resistance? Which of this building is stronger? Reinforced concrete walls or unreinforced masonry walls? Reinforced concrete, залізобетонні монолітні стіни. Unreinforced masonry, неармована кладка, неармована кам'яне мурування. Якщо аналізувати конструкцію, то залізобетон він завжди вкратно, в рази набагато міцніший порівняно з кам'яною кладкою, з кам'яним муруванням. Саме тому, якщо однакові деформації виникли в будівлі, які є суттєво, сейсмостійкість яких суттєво відрізняється, то однакові деформації у різних будівлях, абсолютно коректно було відмічено, що саме ця будівля зазнала більшого сейсмічного впливу порівняно з цим. So, is that clear? So, Konstantin, is it clear for you, or I'll explain from? Okay, thank you. So, and when we are talking about our Ukrainian scale, by the way, this picture is also from Ukrainian scale. This is European. You see, it is the same building. I don't know why they haven't found such picture from Ukrainian earthquake, but nevertheless, same idea, but only in Ukrainian. And the level of damage of this building equals 3. And further, we will discuss those two scales from the point of view what same and what different do they have. I want to tell you that this European microseismic scale is based on the scale MSK 64. MSK 64 scale was in Soviet Union and also in some European countries. Based on this, on that MSK, it is called MSK. It is Medvedev, Sponhaier, Kornik, Russian, German, and I don't know, Serbian. I don't remember, Serbian scientists. They created that MSK scale. Then Europeans made this EMS scale, and based on this scale, we have developed our own Ukrainian scale. It is almost the same, but I will show you what difference do we have between those scales. One more time, from this point of view, we have to admit that both scales have same examples. And way. Next slide, we will start discussion of those scales. When we talk about Ukrainian DBN scale, it measures the intensity of the earthquakes from 1 till 12 in grades. It's some grades marks. When we talk about EMS scale, they don't have any intensity measures. So they only tells that the intensity of an earthquake 10, 11, or 9. And what is the intensity? Intensity is a qualitative. It gives an ability to make a qualitative description. It describes quality with the help of the tables. So intensity is a qualitative description of the effects of the earthquake at a particular location, and it is evidenced by observed damage and human reaction at that location. And when we talk about qualitative, it's only qualitative description of the effects of earthquakes that are available through the recorded history. The concept of intensity can be applied to historical accounts. To historical accounts to estimate the locations and size of earthquake that occurred prior to the development of modern seismic measurement. As this thing I've told you previously, using this scale, we have an ability to assess the earthquake intensity of earthquake that took place 1 or 2,000 years ago, or even 200 years ago, or only by analyzing the records or pictures or something like that, or something like that. Next, intensity. Uh, by the way, very important. When we talk about the intensity of an earthquake, in each case we are describing the highest intensity. So, because during one earthquake, two very important buildings was destroyed absolutely, and some got only some cracks. And when we describing that earthquake, we are analyzing the building that got the most damages due the earthquake. Коли ми надаємо характеристику землетрусу, ми завжди враховуємо найбільший ефект від землетрусу. Хоча ми будемо про це далі розмовляти, що певні деформації, певний рівень деформацій і пошкоджень є у багатьох будівлях. І є будівлі, які повністю зруйнувалися, а є будівлі, які отримали незначні деформації. І все це пов'язується з магнітудою, але про це ми трішки далі будемо розмовляти. So, and here how it looks. So, when we are analyzing the consequences of an earthquakes, for example, we have such city. It's Agadir city. A very strong earthquake took place there. And we have found that some buildings had the level of damage which which give us an ability to assess them as 10, intensity 10. Then we have found some buildings that have intensity 9, intensity 8, intensity 7, etc. And only when we have defined those consequences, we have connect those destroyed buildings with the line which called isoseist, and that isoseist shows us the distribution of seismic waves in certain locations. And right now we'll discuss another main objects of the earthquakes. Due to this slide, we were discussing only effects on buildings, but earthquakes having deal not only with buildings, but with the rest of the objects. Коли ми розмовляємо про об'єкти сейсмічних впливів, ми повинні розуміти, що землетруси це не тільки про будівлі, але землетруси є впливовими на інші об'єкти і інші об'єкти відчувають на собі вплив землетрусу. So, first group of seismic objects are living things, so people and animals. We know a lot of histories about the unregular behavior of animals, of pets, due to the earthquakes. We know that sometimes previously, before the earthquakes, snakes showed on the ground. They moved from their underground holes, from their ditches, and they showed above the ground. And such situation always occurs before the strong earthquakes. Also, we know a lot, big amount of of stories about pets that woken up those masters, those humans, and save their lives. Так, ми знаємо дуже багато історій про те, як домашні тварини вони вночі пробудили своїх власників, і таким чином вони врятували їх життя від землетрусів, бо їх така нерегулярна поведінка рятувала життя їх господарям, коли вони власникам, коли вони їх пробудили та вивели на вулицю. Таких історій доволі дуже багато. І ми знаємо також історії, коли змії з їхніх нор вилазять на поверхню. Це дуже масовий такий вплив, і це також передує сейсмічним впливам. Це пов'язано з тим, що дуже часто перед землетрусами є слабкі вібрації, які відчуваються власне такими тваринами, які виходять на поверхню. Таким чином, ми можемо відзначити, що оцінку інтенсивності сейсмічних впливів ми можемо зробити за рахунок аналізу поведінки живих тварин або людей. So, living things are the main objects of the earthquake, and their behavior and the level of their frightened can show us the level of an earthquake. For example, the intensity 5 from intensity 6 differs in the next way. People during the earthquake intensity 6 wake up in the night, and during the intensity 5 nobody woke up, and that shows us the difference of an earthquake intensity and how it influences on the human beings. Also, we have another level of earthquake objects called ordinary objects. It's some crockery, books, etc., etc. For example, during the earthquake, sometimes the interior furniture moves. Sofas, bookshelves, etc. They move from their regular place, and the movement of such objects gives us an ability also to analyze the level of seismic intensity. Тобто такі звичайні об'єкти, типу мебелі тощо, вони надають нам можливість аналізувати також інтенсивність впливу. Тобто, коли ми чуємо дзвін посуду у шафі, то це пов'язано з інтенсивністю близько 6. А коли вже меблі рухаються, то це вже 7 та більше балів. Іноді в дуже сейсмостійких будівлях люди можуть загинути від того, що на них впали меблі. А якщо ми будемо розмовляти про нормативні документи таких районів сейсмічних, як США, то в тих районах в них є правило кріпити усі шафи до стін. Там спеціальні закладні вироби необхідно купувати, їх монтовувати в стіни, таким чином, щоб меблі під час землетрусу вас не вбили. So, ordinary objects are also a good example of that, how earthquake influences on our regular life. And the behavior of those ordinary objects gives us an ability to assess the earthquakes. Buildings. We have already discussed the behavior of buildings. Next important object is the natural environment. So we have an ability to assess the earthquake due to the effects of rock falls, landslide, cracks, and other geological troubles that we can find during the earthquake. So some of these situation, some of these cases gives us an ability also to assess the level of intensity during the earthquake. So to summarize this slide, we have group of objects that gives us an ability to assess the intensity of an earthquake. As we talked previously, EMS and also the Debye scale gives us an ability to make the quality assessment of the earthquake uh, effects. So, living things, ordinary objects, buildings, and natural environment. Do you have any questions about this slide? So that's good. Let's continue. As we seen on the previous slide, we have we had analyzed the behavior of two buildings during two various earthquakes. So we have to know that all buildings are subdivided according to EMS scale to six classes of decreasing vulnerability. Do you know what is vulnerability? Vulnerability is уязвимість. Уязвимість. Тобто в нас є шість класів з, зі зменшуваною вразливістю, українською вразливістю, тобто російською уязвимість, вразливістю. І тому class A class has the biggest vulnerability. It is very vulnerable building, and class F has the less vulnerability, and it is the most earthquake resistant building. F compared to A is the most earthquake resistant building. And let's start with those classes. Main structural materials: masonry, reinforced concrete, steel, and wood. All of those buildings are subdivided according to those specific requirements, or those specific the way of construction. And masonry building can be very vulnerable and have the vulnerability class A, and then they can be very earthquake resistance with the intensity, with the vulnerability class even E in some cases. How is that possible? Якщо ми розмовляємо про будівлі з цегляної з цегляного мурування, то ми повинні розуміти, що деякі з них можуть мати найбільшу уразливість і мати клас А деякі можуть мати навіть клас І. Why is that so? It is connected with the method of construction and also with the material. So in this case, we have a deal with rubble stone or fixed stone or adobe or earth brick. So it is masonry which is burned by the sun. Так, тобто це цегла такого сонячного твердіння. Так, тобто це цегла, яка не обжигається у печі, а це цегла, яка обжигається на сонці. Тобто глина, солома і на сонце поклали, і ось таку цеглу використовують для будівництва. Тобто зрозуміло, що такі матеріали є найбільш сейсмічно уразливими. For example, when we compare these stones with unreinforced masonry with reinforced concrete floors, or reinforced or even confined masonry, and those buildings have a really very big earthquake resistance or less vulnerability class compared to the adobe or rubble stone. Тобто, якщо аналізувати кам'яне мурування, то природне каміння або каміння неправильної форми порівняно з каркасно-кам'яними будівлями, вони суттєво відрізняються, і це обумовлено і наявністю залізобетонного включення, залізобетонному каркасу у цьому кам'яному муруванню, порівняно з цим, коли навіть без доброго розчину укладаються ці каміння неправильної форми. Same situation we have with reinforced concrete structures. For example, when we talk about frame without earthquake resistant design, it can get vulnerability class C, or in some cases even A, and in some cases it can get D. But for example, when we compare it with walls with high level of earthquake resistant design, in this case we have the biggest the highest level of earthquake resistance and less level of vulnerability class. It's almost vulnerable building from the point of from the structural point of view due to the earthquake. Same situation with the steel structure and also with timber structures. Do you have any questions on this slide? No questions. So let's continue. So when we are visiting or attending some region of the city with those blanks of inspection, those inspection blanks, we have to know we how will we assess those buildings. So here are the examples of intensity degrees for the earthquake. So the first intensity degree of the earthquake, it has no effects, no damage, and not felt even the most favorable circumstances. It's unfelt. Scarcely felt, ледве почутне. Це it is the situation that the impact can be registered by specific devices. And for example, what do we know? Do we think about few, many, and most? Few, it below 20%. Many from 20 till 50%, and most it is more than 50%. And then we will use those terms further when we will analyze the higher intensity of an earthquakes. For example, when we analyzing the earthquake with the intensity degree 7, and what we can find. First, objects of an earthquake, it's people. Most people are frightened and try to run outdoors. Many find it difficult to stand, especially on the upper floors. So, and when we found this description of humans' behavior or humans' feeling during the earthquake, we know that the intensity of such earthquake is 7. Let's move to the second objects of the earthquake. Furniture is shifted, and top-heavy furniture may be overturned. Objects fall from shelves in large number. Water splash from containers, tanks, and pools. And that behavior of the regular objects of our life gives us an ability to assess that the earthquake as the intensity of an earthquake as 7. And also, when we are analyzing C objects or buildings, we know that buildings with vulnerability class A have a suffer damage of grade 3 and grade 4. Building with vulnerability class D sustain slight damage of grade 1. So only behavior, not only behavior of building, but also people and regular objects or like furniture gives us an ability to assess the earthquake consequences. In the same way, we are working with the intensity 8, 9, 10, etc. For example, when we're talking about the intensity 12, it is a completely devastating earthquake which gives next consequences. All buildings with vulnerability class A, B, and practically all of vulnerability class C are destroyed. Most building of vulnerability class D, and F are destroyed. The earthquake effects have reached the maximum conceivable effects. So, and when we talk about most, few, and several, we have to remember these few, many, most, few, these definitions of quantity. So this is EMS scale, and here uh, um, here is the behavior of geological effects due to the intensities of earthquakes. Here we can find the behavior of water, hydrological effects, slope failure effects. It's like landslides, rock falls, etc. Also, this gives us the ability to assess the processes of flat ground, like minor cracks or large fissures in ground, and fissures in the ground, and also convergent processes complex like landslides or liquefaction of soils. Liquefaction of soils is the effects where during the earthquake the ground which interacts with water in it looks like liquid moistural structure. Якщо ми будемо аналізувати з вами геологічні ефекти, то в нас є гідрогеологічні ефекти, які у різній мірі проявляють себе на різних водоймах. Є ефекти падіння усього, що пов'язане з ухилами. Є ефекти, що відбуваються на плоскій земній поверхні, типу незначних або значних тріщин або розломів. І є комплексні процеси типу розрідження ґрунта. І коли під час землетрусу ґрунт під дією динамічного руху та води, яка у ньому присутня, перетворюється у щось наподобі киселю, і тому тоді відбувається розрідження ґрунта. І якщо детально проаналізувати, то уся спрощена in short, уся EMS шкала може виглядати наступним чином. So we have same situation also for the DBN Ukrainian scale, and it is absolutely the same for our Ukrainian buildings. And when we're talking about Ukrainian situation, so in Ukraine we have same idea that all the earthquakes can be measured from 1 to 12, and the amount of grade depends on the behavior of people, of the regular objects, and also impact of the earthquake on the environment. And here is Ukrainian situation. In Ukraine, we have additional vulnerability class. if we talk about from A to F classes in EMS, then in DBN we have additional class A1. It is the worst case, it's the worst vulnerable buildings, and here is this Саманне каміння або каміння цегла, глини сонячного природного твердіння. А також в українській шкалі є додатковий найсейсмостійкіший клас це клас F2. Тобто в Європі є класи A, B, C, D і F, а в Україні ми маємо A1, A2, B, C, D, E, F1, F2. And F2 is the most earthquake resistant structure. Though to F2 we have in F2 we have to include such dampers or base isolation system which gives us an ability to regulate or decrease the earthquake impact. Here is one more base isolation system from rubber metal structural elements. So next important point for our lecture, then when we are discussing the level degree of damage, one from 0 no damage to 5 complete destroyment, we have to admit that during various earthquakes the behavior of buildings is various. For example, when we talk about the earthquake with the intensity 6, and here is this curve. So zero destruction we have in most cases of building, and in some cases, in few cases, we have deformation with the level 5, with the fifth level. And when we talk about the intensity degree 8, in this case, some building like turn person have few building have zero damage. Many buildings have damage between 30 and 40%, and few buildings also have was completely destroyed, demolished. And when we talk about the higher level of intensity, like 10, in this case, we see that zero degree damage was almost in none of the building, and most destruction, like 50% of building, was completely destroyed by such earthquake. So here is the this slide, and this diagram gives us an ability to understand what distribution of damages in buildings have place during the earthquake. For example, when we talk about Ukrainian scale, we have this redistribution between degrees of damages, load-bearing construction and non-load-bearing constructions. And here we can find that zero degree of damage is in load-bearing construction is absolutely, we can see absolutely absolute absence of damages, and also for non-load bearing structures. And fifth level, it's a complete destruction. Both for them are equal. For example, third level, average damages which decrease the load bearing capacity of building, and significant damages which can lead to collapse of the structure, which can impact on the humans' health. And here we can see how those scales impact influences on the buildings. So, for example, when we talk about masonry buildings, in this case, we can find various levels of damages in these buildings. grade 1 and grade 5. It's for masonry building, and here is the situation for reinforced concrete structures. Also, and here using these tables, we can define what kind of deformation have we got or have we found at the certain construction site. When we were talking about first slide where we found in Italy these cracks between windows, this gives us an ability to make a conclusion that the grade of damages in this case was 3. Same situation in the Ukrainian building code, same situation. And Ukrainian intensity scale, vulnerability classes you can find here from A1 till F2. So here is, so there you are. That's all for today. Do you have any questions about intensity scales? So no questions at all. So that's all for today. See you next week. Bye.